Our next speaker is the hardest one to introduce because I don't understand any of this, right? So if you're trilingual, if you speak 3 languages, they call you trilingual. If you speak 2 languages, they call you bilingual. And if you only speak 1 language, they call you an American. And that's kind of where I stand. So, but apparently there are languages that you speak backwards. This is the only thing I can think of, right? So anyhow, this is Yana Margolin. She's a Googler, and she speaks backwards. And she's going to teach you how to speak backwards as well.
Okay. Thank you, James. Okay, thank you, everybody. As James said, my name is Yana Margolin. I'm from the Google Israel office. And today, myself and my colleague, Jason Elbaum, from the same office as me, will tell you a bit more about BiDi testing, and specifically automated BiDi testing for the web. Okay, let's just see that this is working. Great. Okay, so first of all, what is this BiDi thing? Pretty much any language you can think of is written in a left to right order. For instance, English, German, Spanish, and so on. Some languages, however, insist on being special and being written the opposite way, in a right to left order, such as Arabic, for instance. But not only that, these languages still include some elements that are written in a left to right order. For instance, you can see here in the first example, there's a phone number. The phone number is always written left to right, or embedded left to right strings. In the second example here, there's a Hebrew sentence, and the word cool in English appears in the middle of it, and obviously is read and written in the opposite direction than the rest of the text. Because of that, we refer to right to left languages as being bidirectional, or BiDi in short. Okay, so BiDi languages include Arabic, which is, I mentioned before, Farsi, Urdu, Hebrew, and some more languages, less common ones. In total, we're talking about 500 million speakers and about, I would say, 140, 150 internet users. It is important to note, 150 million internet users. Quite a difference. Yeah. It's important to note that the internet penetration in right-to-left speaking countries is about 20%. So there's a lot of room for growth. And it's quite an important market share for us going onwards. So that's why BiDi support in web applications is so important. Okay. So this is a quick example to illustrate how easy it is to come across bidirectional data on the web. What we have here is the Google search English UI. Without user input, the UI contains only left to right strings. It's entirely in English. It doesn't have any right to left or bidirectional data. But here comes the user. It's a right to left speaking user. And as many of right to left speaking users, it prefers to use the left to right UI. Why? Because it's the default one, it has more features, or any other reason. Okay? So he opens the Google search English UI. It types in New York in Hebrew. And you can see that already within the snippet of the first search result, most of the snippet is right to left. It's in Hebrew. But we already have 3 appearances of New York in English. So voila, that's bidirectional data for you. Even though you thought that probably the chance to get bidirectional data in this English UI is minimal, you can see how easy it is to trigger the appearance of such data. Okay. So how does a web browser knows to display bidirectional data? That's what the Unicode BiDi algorithm is for. You can see the entire algorithm at the address mentioned on top of the slide. It's pretty long, so I won't bore you with the whole details of it. What's important for our tech talk today is the following 3 key ingredients. First of all, this algorithm divides characters into several types according to their directionality. Right to left, left to right, and several kinds of neutrals. The second thing which is important to know about this algorithm is that it determines the visual order of the characters, how they will actually appear on your screen. And it tries to work properly without being explicitly told where left to right or right to left text begin and end, but it still needs some help to function properly, as we will shortly see. Okay, so in addition to supporting the appearance of bidirectional data within a regular left to right UI, if we want to support BiDi properly in an application, we would usually want to create a right to left UI for it. To show you an example of how it's done, we have here the regular left to right English UI of Google Books. You can see that the overall directionality of the elements in this UI is left to right. Google Books logo and search results thumbnails appear on the left side of the screen, while the ads appear on the right side of the screen, for instance. One more thing I want to note here is you see that the UI is once again completely in English. The user even typed in an English query. It searched for Italy, books about Italy. But the ads here are in Hebrew, and they contain bidirectional data. Once again, you can see how easy it is to trigger bidirectional data appearance within web applications. OK, so we have this UI. And we want to create a right-to-left version of it. For instance, turn it into a Hebrew UI. What we get is pretty much a mirror image of the UI we saw before. If we shift quickly, you can see that it's pretty much mirrored. The logo of the product and the thumbnails are now on the right. The ads are now on the left. Looks pretty much like a mirror image. But it is not that simple, obviously. I want to illustrate this using these lovely images of Mona Lisa, George W. Bush, and Margaret Thatcher. We took these images and mirrored them. Can anyone see anything wrong with them other than the fact that they're upside down right now? They look, yeah. OK, good. You must be a QA person. OK, so yeah. Although they may look quite all right like this, if you look at them in the right direction and not being upside down, you can see that they don't look that good. This is what happens when you mirror a UI and don't pay any much thought into it and don't provide BiDi support properly. You might think that the UI was mirrored properly, but the user that will try to use it will immediately see what's wrong with it. OK, so how do we do it properly? First of all, we need to declare the overall directionality of our UI. For instance, if we want to create an Arabic UI, in order for the elements in the UI to appear correctly, the first thing we want to do is add the dir equals RTL attribute to the body tag of the HTML of the pages. This attribute affects default paragraph alignment. After you add it, the paragraphs on the page will be by default right aligned instead of being left aligned. It affects neutral items at the beginning and end of blocks, punctuation, images, inputs, and so on. And it affects tables. The order of the columns within the tables are now right to left instead of left to right. And of course, all the data within the table, all the text, is now aligned to the right and appears with right to left directionality. One important thing to note here, this attribute doesn't take care of most layout issues. The layout issues are determined by CSS, and we will not go any deeper into it in this talk. OK, so this is our beloved Google+. We decided to create a Hebrew UI for it. We took the English version of the UI, translated some strings, and gone something like that. Well, a right-to-left speaker user who sees that, it looks as incorrect to him as this does to you. For instance, you can see that the data within the post, it's not very readable. It appears garbled. In order to fix it and create a proper right-to-left version of this UI, what we need to do is add the body dir equals RTL to the HTML of the page. And you can see it looks much better now. The text here is readable, appears with proper directionality, and is properly aligned. OK, so this is the first step that you need to do when you create a right-to-left UI. You've done it. The user starts using it. He's very happy. He types in right-to-left data. Everything works fine. But then, once again, the user is not a fool. He wants to enter any kind of data he wants. So this is the Google Plus profile page, the About tab. As long as he enters right-to-left data, it appears properly. But then he decides to enter his work address in English, 17 Main Street. And look at how it appears. It's not really readable. The 17 appears on the incorrect side of the phrase. So is the period at the end of the sentence. Doesn't look too good. OK, so we want to fix this problem, but without breaking the rest of the UI, because the rest of the UI is fine. How do we do it? We surround this part with a span tag with, once again, the dir attribute. And this time we say dir equals LTR to signify that this part is left to right text and should appear as such. You can see that now the address appears properly. It is readable. And the rest of the UI remains unchanged, still appears properly. This span dir equals LTR or RTL attribute is also useful in the following cases. For instance, in the second row in the table, you can see garbled leading punctuation. OK is not OK. The opening quotes appear in incorrect location. If we surround that with span dir equals LTR, this will now appear properly and resume its original meaning. Same thing happens if we have a left to right page and we want to insert some Arabic data. For instance, to say marhaba, which is hello in Arabic, followed by an exclamation mark. If we don't do anything, it will appear incorrectly. The exclamation mark will appear on the incorrect side. If we surround this piece of data with a span tag with dir equals RTL attribute, it will look properly and once again be readable. OK, so one last thing I want to mention before my colleague Jason will come and tell you how to find these type of bugs automatically is the text input boxes. What we have here is the Google Maps Hebrew UI with the search box. And usually, we would like to enable directionality auto-detection for these search boxes, which means that as the user types in the data, the directionality of the data is determined on the fly. The user doesn't have to do anything, and the data is displayed properly. In the first example, 17 Main Street, as the user typed it in, it got recognized as being a left to right string, and it appears with proper directionality and aligned to the left. In the second example, the user typed in a right to left query, New York in Hebrew. It got recognized as being right to left, it got aligned properly, and it appears as it should. Having said that, for some input boxes, we would like to enable fixed directionality. No need for this auto-detection to take place. For instance, input boxes that contain URLs. URL only contains English letters. It should always appear with left to right directionality, so the directionality for that field is supposed to be fixed. OK, so thank you so much for your attention. I would like to invite Jason to come up now and tell you a bit more about how you find these bugs easily and automatically. Thank you.
What do I do? Thanks, Yana. Hi. I've to apologize. I got a bit of a cold, so I'll be steering clear of Alberto. I understand that test is dead, but let's try it anyway. Let's see if we can be manual BiDi testers for a moment. We're looking at right to left search interface with a left to right query string. And what we're looking for is opposite directional text, which is embedded somewhere. And typically we have punctuation or numbers which surround it and which end up on the wrong side of the letters. Anybody? Okay, I think we have a few spotted it. Now, it's quite possible that A Space Odyssey 2001 might have been a better title. You have to take that up with Kubrick and Clark, but meanwhile, so what's going on here essentially is that we have an embedded phrase which is left to right directionality and which is basically needs to be wrapped in a span with directionality LTR because otherwise essentially the browser sees 2001 at the beginning of the phrase, and the beginning of the phrase from its perspective here is right to left. It starts on the right side, and it gets it wrong. Apparently everywhere else on the page here they got it right. That's already pretty good. Let's try another one. This one is more subtle. The one I'm thinking of is up there. The URL ends in a slash. Now, you might say this isn't very significant. It might not be very significant in this case. In other cases, depending on the actual data that appears there, the garbling may be more severe, may interfere with the user's actual ability to use the page correctly. Here's a map address, a search result for maps. And by now, I imagine you've probably found this one. So if you were trying to find your address in New York City, you wouldn't really be able to give this to a cab driver. He wouldn't know how to find 5th Avenue 350. Well, he might, but maybe if he spoke Hebrew. There's another one, actually. It's a little harder to spot if you look a little closer. Just below that, we have the subway station, which is on 34th Street, and it's not Herald Square 34. And so these are examples where you might not be able to find a street sign to see where you're going, or you might not be able to give this address to somebody in the real world to get where you're going. BiDi garbles can actually cause real problems for real users. And you may also notice that these are hard enough to spot. Imagine if you're trying to debug this in the other case, where we have a left-to-right user interface and the data is in a right-to-left language. The data is in Hebrew or Arabic, and you're trying to spot these instances when you don't even speak the language. So now, by this point, you're saying to yourself, wow, I wish I had an automated tool which could find these problems for me. Well, you're out of luck, so no, not quite. So we have a tool we call BidiChecker. It's developed inside Google. And it basically runs, it's a JavaScript library. It runs embedded inside the page, scans the DOM for a number of common BiDi errors, the most common of which is undeclared text, which has the opposite directionality of its context. So here, for example, pops up a little UI on your page. It lets you browse through the errors and gives you the description of the error, its location on the page. It's at Street Herald Square, which is the English text, which is not declared. And we have a little hierarchical list of start HTML tags to give you a sense of where exactly on the page you can find it if you're the developer. This is actually a somewhat primitive UI. We're working on release number 2 of the UI to let you organize and browse and categorize your errors more effectively. But it's effective for what it is, and talk a little bit more about how it's used. Oh, okay, I'll talk a bit more about what it's there for. So objectives, number 1, to make it easier to facilitate the initial development of BiDi support in a product, which means that as the developer, you can run BidiChecker on a page and get a list of potential errors, scan through them, identify what's causing them, and go back, iterate your development and fix them. Objective 2, You might say, well, yes, we can test for all these things. I can put in a unit test and check that this field is declared left to right and that one is declared right to left. And that's true, but that only catches the things that you're looking for. That will only find errors that you're explicitly searching for. BidiChecker scans the entire page and therefore can find errors and features which have been added since your unit tests and features which you haven't remembered to add tests for. So it'll trap those for you as well. And then finally, there's the whole regression test use case where it's running in your automated suite. Somebody adds a new feature, forgets to handle the BiDi wrapping. Your test fails, the test suite fails, the product alert goes up, and everybody goes and does something important about it. So here's a bit of sample code in a JavaScript unit test. We have a test function. We start with a little bit of code in your application domain to navigate to wherever it is, navigate the page to the scenario you want to test. And then we call BidiChecker. We got a check page function. It takes a couple of parameters. One is a Boolean indicating the expected directionality of the page, right to left or left to right. And then there's the element that you want to test. Usually we're testing the whole page. Sometimes you might want to test a particular frame or a particular element depending on your test environment and the structure of your application. And it returns a list of error objects. Typically, we're going to assert that that list is empty. If an error comes up in BiDi support, the list won't be empty. The test will fail. Your test framework will give you a nice little message telling you what went wrong, and then you can get to work. Let's say a few words about error suppression. Why would we want to suppress errors? And this is actually a problem common to many automated testing tools. First of all, not everything that the test tool identifies is a real error, false positives. Examples in our case are product names, which might always appear in English, for example, even in a right-to-left UI, or an acronym like HTML, a file format, things like that, which appear on the page, which we know what they are, they're fixed, they're not going to change, and they're not going to become garbled. They're not going to be replaced by the user with some phone number or address. So it's not worth investing the engineering effort to fix the directionality declaration of it. It makes it much easier, it's much more sensible to just disable that error from appearing in our list. Case number 2 is known bugs. We've already found this bug. We know it exists. We filed the report. Somebody's working on it, or somebody isn't working on it, but there's no point in breaking our test suite for it anymore. And the third case we're referring to is somebody else's problem. We have, let's say, text that we're bringing in from elsewhere on the web. There's nothing we can do about it if its BiDi support is wrong. Or we may have a module that we're inserting from another team, another project area. It's not our responsibility to fix it, so we can filter that from our results. There's an example. We have a little navigation list with a number of other products. One of them is Gmail. Gmail is a name, is a product, a brand name. We don't translate it. It just appears as Gmail everywhere. But it's not causing a garble. It's not disrupting the flow of the page. So instead of getting this annoying error from BidiChecker, we can add a little code to filter it out. We are creating a filter, calling our filter factory @text filters out all messages, all errors which appear at the particular text string Gmail. And we just add our filters to the call, and now our test will run clean again until a new error crops up that we haven't yet encountered. And we can filter errors on basically all of their fields, on the text, on the severity, which I haven't talked about, on the location on the page, either by the ID of an element that contains it, or a class name, or XPath. We can match on a regular expression or a literal string. We can combine filters with and or, and not. It's both flexible and powerful and simple error specification language. Finally, a few words about designing test cases. In general, there are two main types of scenarios that we want to test. One is when we have a left-to-right interface, and we're going to handle right-to-left data. So we have left-to-right Google+, and we are inserting here all kinds of right-to-left content, and we want to make sure that that is correctly handled. So we would need to set up a test case which seeds the application with right-to-left data. And preferably seeds all of the fields, as many fields as possible that might handle our RTL data we want to seed, so that when we run our tests, we're checking, our check is as comprehensive as possible. This sometimes is technically very difficult because some test suites, some application test suites are not designed to be seeded with data per test. It's a problem, but it's a fact that you often have a test suite where you run all your tests on the same data set. And you're not going to go start generating special data just for your BiDi tests. So in that case, the only type of scenario we can realistically test is the reverse case of a right-to-left interface and your existing standard left-to-right data. And then, again, every field preferably filled in, every field which handles left-to-right data in your right-to-left interface, that handling will be checked and flagged. For our own convenience, it's ideal if our data also starts or ends in numbers and parentheses and punctuation and other sorts of things which are visually garbled by the BiDi algorithm. That doesn't matter to the tool. BidiChecker will catch any undeclared opposite directionality text, but you'll look at that and say, well, I don't see the error there. It looks fine to me. The moment you have an exclamation mark or a parenthesis or a number on the wrong side, you can also, as the developer, visually spot the problem in a way that you can't if the text is visually unchanged. But why do I want to flag an error if it's visually unchanged? Because the data is going to change. The user is going to give me data which has problems that my test suite might not be covering. So it's important that from our perspective as the developers, or the testers for that matter, that we're seeding it with data which will visually be garbled by the BiDi algorithm. Again, the tool doesn't care, but we do as humans. And the resources, BidiChecker is an open source project hosted on Google Code. And you're welcome to check it out, download it, give it a whirl, and contribute back should you so desire. We also have a reasonably comprehensive document about how to implement BiDi support in a UI. It covers everything Yana covered, plus a number of topics that we didn't get to here. We call that the BiDi how-to, and that's also available. And finally, along with the regression test, the automated testing scenario that I demonstrated, we have a bookmarklet that you can install in your browser. You drag a link to the bookmarks toolbar, and then you just click on that on any page in the browser. It will install the JavaScript, run it on the page, give you your little UI, and let you figure out what's wrong with your pages and your competitors' pages. And everything like that. Now, I have to remind you, of course, that that's only really useful when you have BiDi data on the page. We can run this on Google Search in English with an English query, and it's going to do great, really. No problems there whatsoever. That's what we have for you. Happy to take questions, comments, tomatoes. Sure. Oh, okay. Yeah.
This isn't really a testing question, but you sparked my curiosity. You mentioned a couple times, well, she mentioned a couple times, auto detection of BiDi languages.
Yeah.
What processes and methods do you use to do that kind of detection?
Okay, well, the simple answer to that is that there is code, JavaScript code out there. Google Closure Library, for example, has functions which do this, and you can just hook that into the what's it called, whichever trigger it is that you need to hook it into in the input box, and then every time the user adds text to the search box, it will auto-detect the directionality. To be a little more specific, there are different types of detection, different algorithms, heuristics that are used to determine if something is left to right or right to left, because it could be mixed, for example, or it could have numbers, and then you have to decide, do I want to call this left to right or right to left? And that's a whole different question of how you do it, sort of methodologically. But technically, yeah, there's JavaScript code out there that you can hook into your page, which will do that, and you can just do that for every input box, which might be bidirectional. Yeah, sure.
So when you were showing the Google Plus interface UI, I just saw that the picture of the icon of home is not correct if you apply Bidi, because now like avatars are on the left and all the text is on the right, whatever. Just so the question is, do you have any algorithms of verifying, identifying,
Oh, this picture. I see. That's interesting. Okay.
Bidi text or something on pictures, because like I can think of banners that have that were not translated actually to Bidi, and you can't just mirror them, you know.
Yeah. So your question in general is, what do you do about images, some of which are directional?
Yes.
And most of which usually are not directional. And as far as I know, the only way you can really identify that is manually. Just because a picture has a directionality doesn't mean it has to be reversed for Bidi. Like, you know, those circles have a particular directionality, but nobody would care if they were reversed, for example. But if you have arrows, then the direction can matter a lot. You flip the order of them, and they look wrong. So the only real way to trap that is manually. I'm not aware of an automated way to identify it. Now, we do have automated tools to flip images. And I think, if I'm not mistaken, that HTML, maybe HTML5, I don't remember, actually has an automatic way to flip the directionality of an image. I'm not sure. I could be wrong on that.
So the problem is that you can't just flip any image.
No,
right?
you can't flip all the images.
You can't actually flip images at all. So like for the home icon, you can do that actually, but mostly you can't.
Now, in this case, you know, it might not matter. The other answer is, yeah, it looks a little backwards, but nobody's going to notice it's an icon. And it's really a judgment call, and it depends on the type of image, and it depends on the context. And
so you basically only automate text checkpoints, not big. You basically only automate text, not like images, right?
At the moment, this test tool, BidiChecker, is only testing the correct handling of the flow of the text. There are other kinds of ideas we have for further types of automated tests, but that's currently what we're covering. Yeah.
Okay, thank you.
Sure.
Anyway, you showed us a really nice tool that can show you exactly what's wrong and where it's wrong.
Right.
Why don't you use that to autocorrect?
Yeah, autocorrect. Why don't we use the same tool to autocorrect the problems? The short answer is that it's not really possible. That if I go back to one of the examples, let's say here, right? So we know that we have a space odyssey, which itself should be declared as left to right. But where does the 2001 belong? Is the 2001 part of this introductory text in Hebrew, or is it part of the movie title in English? Where does that break occur? And an automated tool has no way of knowing what the correct answer is. In fact, the only way to really get this right is for the application, which embeds the data in the string. We have a string here that says, here are the video results for this query. And the application knows that this is the query string, and this is the surrounding template text. But the automated tool, which doesn't see the template system and it doesn't see the semantics of the different components, it doesn't know how to do that. It doesn't understand how to break this down between template and embedded and et cetera. So in the general case, there's no real way to fix it automatically. Yeah.
Are there any more questions?
Okay.
Okay, great.
Thank you very much.
Thanks, Jason. Thanks, Yana.